And for a final thought on artificial intelligence and its potential impact on the mining industry is Janice Fingler, who's going to share a brief presentation on keeping humans in the loop, I think, in some way, shape, or form.
Good afternoon. I'm going to give you guys just a little tour of some thoughts that came bubbling up on Monday, actually, because at UBC BRIMM, as part of our work plan, I'm helping to explore the area of decision-making in this complex environment that we have. From hearing about the challenges, and how do we create that substrate? You heard in the Hatch presentation, that's very important. How do we build capacity to be able to move forward together? And one of the things that we did, as I walk you through what this presentation was about on Monday, I want you to think about in the context of AI and technology and human solutions coming together. Consider all of the spots that humans are part of that development of technology solutions and AI solutions as well, right from the development of the product or the software, from you connecting in with all of the supports that you need, making connections into the company. You have a champion, maybe you have some buy-in, or in the organizations, maybe you don't. How do you go forward in terms of adoption and sustainability? So thinking about all of those interactions, I'm going to take you on a journey of a different kind of data, information, and knowledge through this expert that we had join us on Monday. Now, I came to meet this fellow, Dave Snowden, about 10, 15 years ago when I was at my peak frustration in the mining industry. It was not only me, but a number of colleagues, because we were, after decades in the industry, you could see these what looked like repeated patterns of doing things over and over again, investing a lot of effort in one area with diminishing returns or not the results we wanted. And it just seemed like mismatches were happening all over the place. So I actually stepped away from the industry and that knowledge base there, and I went out almost into the wilderness of other sectors, trying to get ideas of what was going on. And as I went to explore these areas of thought leaders, and Dave Snowden is definitely one of them, and what I was looking at in particular, I wandered into this world of complexity science, which very much resonated with me as a scientist. And Dave Snowden is actually an applied complexity leader, global thought leader, actually, he has created the School of Naturalizing Sense-Making. So he's a global leader in these approaches around decision-making, collaborating, based on nature, not only in the physical world, but also, how have humans evolved? So he actually came out to UBC, very gracious, coming from Wales, and the name of his company is Cynefin Center. Cynefin is a Welsh word meaning multiple places of belonging of which we're only ever partially aware. And that very much fits the world of complex decision-making that we're often in with the work that we do. So I'm going to walk you through a few points. As you can see, he started off with this interesting slide. You can see that estuary. And I know those of you who might not be near the ocean might not recognize this, but there are places, where the fresh water, salt water can mix, tides turn. There's different organisms that are out there, different birds at different times, different landscape, very dynamical environment. And there are only some things you can do at certain times when the tide turns versus not. It takes a lot of awareness. So this is a metaphor that he uses. So I'm going to share with you a little bit about what Dave talked about with us. Now, he opened with a story about, actually about a research paper that was done with a College of Radiologists. And so as a group of radiologists, And also the reviewers of the College of Radiologists did this exercise where they were given an image, as they would usually do to review for cancer. And in that image, there was instead of a nodule, superimposed was a picture of a gorilla that was like 48 times the size of a cancer nodule. And the interesting thing is, as they scanned through and did the results, 83% of those experts, deep experts, did not identify the gorilla in that image. They did not see it. But 17% did. So what was going on? Like, I mean, that's confusing. And now we see, oh, well, that's why we have, technologies helping in medicine to do these scans. Even deep experts can get it wrong. Very interesting. It was even though their eye tracking software went right over top of the gorilla, showed that they looked at it. So think about that now. Deep experts not getting it right, but yet this outlier group, 17% that did. And what does that mean? Well, we don't see as human, we don't see what we don't expect to see. But yet we, as individuals, as a group, we can start to see some differences. And that 17%, think about when you're in meetings designing things, that we have to consider that. Who is that group? So Dave took us on this journey into what is complexity. We often think about complicated things. If you're building a product, you want to have repeatability. If you're making a process, maybe you want repeatability. Those are complicated, comes from a word that means folded. Things you fold, you can unfold or refold. But with complexity, that comes from a word that means entangled. And it means that they cannot all fit together. And that's often what we're dealing with in all of those human interactions. Now, there's a whole new language that we learned from Dave related to what are the elements of these complex systems. And you can see, those are interesting words for sure, but in summary, we think about it as almost like dots. Like you can see, I'm wearing a top with a bunch of dots on it, and even on these Lego blocks. But if you took 4 dots and you took lines of interaction at linkages, you could have 16 different linkages from 4 dots. And from that, you could have 64 patterns. Now, if you ended up with 10, you had 10 dots, very quickly now, the number of patterns that can come out are over 3.4 trillion. Now think about when we talk about all these factors and drivers in a human system, and even in is it really knowable for us to handle all of these things as humans, or even in designing our technologies? You can see it's common on the left there. The bell curve is very common in traditional risk management, or even you see about if you have a baby, your child's in the 95th percentile for the length or the height, things like that. So a lot of things are managed based on a bell curve, but in nature, over on the right, there's a number of patterns that actually follow a power law distribution. And that is the area of the human system and the complex systems we need to pay attention to, because it means like way over on the right there, those are the big outliers of events that can happen for better or for worse. And we cannot see all of those trillions of interactions. So there is risk and opportunity in that, but we need to recognize that, hey, that there are systems in nature and situations that follow the power law, and that's the world we work in mining. And as you can see, when we superimpose those together, the bell curve is in blue, and we put the Pareto curve on top of it. Look at the gaps in there. Instead of managing to the middle, you can see over on the right, we can handle all those things in the middle, in the probable domain, traditional risk management in your register. And then when you go into the possible domain, that's your scenarios that you're trying to work through and perhaps even program in there. And then, but look at out on the right. See that big long tail out there? That's bigger than we can ever imagine and ever know. And you probably hear about the black swans, things like that, unknowable. And small things actually can cause very material changes because we don't know which patterns they are all connected with. So it's important when we have these AI systems to consider that. But out on that far end on the right, that is the human advantage, because that is the capabilities that humans uniquely have in being able to be that 17% of noticing and being surprised and wondering. And are you building that into your systems, where your technical systems are augmenting human cognition and not replacing it? So think about that, because humans we think about, like with that radiology, they can be a risk, right? You heard some examples like, hey, why are they doing the wrong thing? They have lots of data and stories, experiences in their heads as well, that you're never going to see all of that data. None of those data points or interactions, or even with each other. And for example, even in your design, you will hear about the Boeing aircrafts that go down one line of code, or they didn't have the verification code. So do we really believe that we can design all of that out of the system? Or maybe we should consider including the people in the system to also help to be pattern spotters for us in that. Like, can they be signaling back to your technology, have a badge underground that they wear if they're in an area of autonomous vehicles, where they can signal, like pulling the end and cord of what they notice and maybe stop the system and have override capabilities? Can they see other patterns for us? That is what we're looking to do with our human systems, because they're going to see opportunity as well. And that area on the right-hand side of the curve is where you're going into the realm of that creative destruction lab, and how can we generate and be working together. So we need to be operating in that domain, but working differently and choosing to assess where on our projects, organizations, even in our meetings, is this a complicated situation where I can know the pieces, or is this a complex situation? And then you're into that area of probe, sense, respond, and also listen to the human narratives. And one example is, imagine you're trying to go into to introduce your technology or your innovation to different groups on a site. Well, there is actually a lot of tacit knowledge there among workers. And I've seen this myself in mineral exploration, where core logging systems came in and they wiped out, then they eliminated our opportunity to write in or indicate what surprised us. We lost that advantage in exploration, and I believe it makes us less resilient because of that. So are you designing that into your systems, that you can have the human interaction, the human contribution to bring that qualitative data into your system? So now we're talking about structured data, unstructured data, and unstructured human data. And we're going to be going forward in with BRIMM and the MICA network. I'm putting a proposal forward to actually do some of these ethnographic scans to try to pick up ways of mapping the patterns that the humans are noticing, the things that are the meaning below the waterline, so that people like me and other parts of these organizations are not sat on the sidelines. Because you know what? It's the 17% that might just give us that edge. And they're often it's the cynics who care the most. Thank you.